Welcome back. The objective of this video is to define arithmetic sequences. We'll write a formula for an arithmetic sequence. We'll find terms within an arithmetic sequence. So as we saw in the last video, arithmetic sequences have the same differences between terms. So our difference, if we took the second term, subtracted the first, and we get a value, and we took the third term and subtracted the second, we get the same value, that D is our common difference between terms. So if you have your notes from the last video, in sample 2 here, you can see we had a common difference in A of 3. Each time we added 3 and got our next term. So in 3a, we had a common difference of 5. Now you can have a negative common difference as well, but here in B, you can see that we did not have a common difference. We went plus 2, then we went minus 2, then we went plus 2, so that is not an arithmetic sequence. But these other ones in 2 and 3, for A anyway, are arithmetic sequences. So an arithmetic sequence is written here in the, you can see this on the right hand side, a sub n equals a sub k plus d, d is our difference, times n minus k, where a sub n, that's the value, or what I call the value of the nth term. A sub k, that's the value of the kth term, some term in the sequence that's not the same as n. D is our common difference, and then n is the location of the nth term. Okay, so the fifth term would be in the fifth spot, but the fifth term might have an a sub n of like 20. Okay, and then of course k then is the location of the kth term, so the 7th term, the 8th term, the 20th term, the 30th term. Not its value, but just where that lands in the sequence. Okay, so that's the location of the kth term that has a value of a sub k. So n is the location of the nth term that has a value of a sub n, and this is for all n's that are greater than or equal to 1. So our explicit form is on top and our general form is down below. This might look a lot like slope-intercept form, or a y equals mx plus b, where a sub 0 is our kind of our y-intercept. That'd be the 0th term. M or d is our difference, our rate of change is our d. So, and then the 0th term is just the first term minus the difference, which intuitively that's pretty easy. So if we look at this example 4, is the sequence an arithmetic sequence? If so, write the general rule. Well, our common difference here is a positive 4 from 1 to 5, 5 to 9. So our d is positive 4. The a sub 0th term is 1 minus 4, or negative 3. So that's our y-intercept, if you will, and our d is 4. So we can simply write our formula for our sequence as a sub n equals 4n minus 3, where 4 is our common difference and minus 3 is the value of the a sub 0th term. In example 5, we're asked to find the 46th term of the sequence, 2, 5, 8, 11, 14. So our d here appears to be a positive 3. So d is positive 3. Our a sub 0th term is just going to be 2 minus 3. So our a sub 0th term is negative 1. Our sequence is a sub n equals 3. Our d is n minus 1. And we want to find the 46th term. So a sub 46 equals 3 times 46 minus 1. And 3 times 46 is 138 minus 1 equals 137. So the 46th term is 137. Example 6 is giving us a problem and it's putting in vocabulary or just in sentence form what we gleaned from the actual sequence. So our first term is 8 and our common difference is -5. So a sub 1 equals 8. Our d equals -5. So our a sub 0 term is 8 minus a -5. So our a sub 0 term is 13. So our sequence is going 13, 8, 3, etc. Find the 9th term of the arithmetic sequence. So our formula for our sequence is a sub n equals -5n plus 13. So a sub 9 equals -5 times 9 plus 13 is -45 plus 13. So a sub 9 is equal to -32. Example 7 is more of really what we've been doing. The numbers in the sequences follow a general pattern. Can you write the general rule? So we have 1, 1.25, 1.5. It looks like our d here is 1/4 or 0.25. Our a sub 0 is 1 minus 0.25 or 0.75. So our formula, a sub n equals 0.25n plus 0.75. I'll leave B for you to do and bring that to class. I bet you can do that one. And we'll move on to number 8. This one's a little more complicated word problem. The number of seats in the first 16 rows of an arena form an arithmetic sequence. If there are 20 seats in the first row, 23 seats in row 2, how many seats are there in row 16? So I don't want to write this all out, but our first term is 20, right? That's going to be row 1, and then 23 in row 2, and 26 in row 3, and 29 in row 4, and so forth. So our common difference here is a +3, and our a sub 0 is going to be 20 minus 3, or 17. So it gives us a formula of a sub n equals 3n plus 17. Now we want to find out how many seats are in the 16th row. So we want to find a sub 16. So 3 times 16 plus 17. 3 times 16 is 48 plus 17. So a sub 16 is equal to 65. So there are 65 seats in row 16. And we'll get some more practice with arithmetic sequences when I see you in class.